the topic today is errors in sampling. So this chapter, and for a lot of what we're going to do for the rest of the semester, is much more about thinking and explaining than it is about calculating. When we introduce errors in sampling, first we need to talk about what a sample is. So you have your population. That could be everyone in the world. It could be every person at Shortridge. It could be everyone in our class. Whatever you want to study. That's the whole thing. But it's often impossible to survey everyone or everything, so you just ask a sample. And that's a small, maybe it's big, but it's just part of the population. So if you could ask everyone in the population the question, you would get, in theory, perfect results, but usually that's impossible. If you wanted to find out how tall every person in the world was, by the time you got done asking the first time, more people would have been born. It's just impossible to do. So instead, we're going to ask a sample. Okay, you're just going to ask 1,000 people, or you're just going to ask 100, or however many you can. The downside of just asking a sample is that it may be inaccurate. Whenever you're not asking everything, or everybody, or everything, there's a chance of having some error, meaning that the conclusion you make from the data is not true to real life. So as an example today, we're going to use height of Shortridge students. Height of Shortridge students. Okay. So there's 4 types of errors that could occur. We're going to use the same example of height of Shortridge students for all of them and see what these different errors mean and how you can avoid them. The first type is just called sampling, like the word sample, sampling error. And this one you can't actually avoid. It's just because no sample is perfect. No sample is perfect. Even if you made no mistakes, if you don't survey everybody, you might not be totally accurate. We accept that. That's okay. The other 3, though, we're going to try to avoid. The next one is called measurement error. So this is like, even if you ask a good sample, you got to make sure that your data is good. So measurement happens if your data is bad. Okay, it can be bad for a few different reasons. So to prevent it from being bad, one thing you have to do is measure accurately. If you're measuring how tall everyone in the school is, you're not going to just stack a bunch of rulers on top of each other. You're going to measure accurately. Make sure that you have a professional, like a doctor, or someone who knows how to measure somebody. Use real tools so that you can measure accurately. You also have to be consistent, meaning always the same. If you, even if you have good tools, if you're not consistent with how you're measuring, it's not going to work out. So, for instance, in measuring height, you would want to make sure that everyone's wearing no shoes, because obviously some people are wearing shoes, some people aren't, or if shoes are different heights, some people are going to be off. It's not consistent. Also, you'd want to measure at the same time. People tend to be slightly taller after waking up because as you're lying down, your body's not being weighed down upon. So you want to measure everybody in the morning. And your measurement also has to be unbiased. Now, unbiased means there's no bias, there's no direction to it. So with height, a lot of people want to be taller. If you just asked people, don't do this, if you just ask people how tall they are, then you're going to end up getting people saying they're taller than they actually are. That's called a bias. People have some preference they're wrong in some direction, so your data is also no good. Your data is bad. For instance, with height, if you look at the rosters of college basketball players, they're often, point guards listed at 6'2". When they get to the pros, they're actually 5'11". They're not actually getting shorter, but when they're actually measured professionally and unbiased and asking the coach, they're actually doing it professionally, you get the true data. The other two kinds, the next one is called coverage error. So an error in how much you're covering the data. And this would come about because your sample is not equal to, or might not even be close to, your population. So, of course, if you're not sampling everybody, your sample is not the same, but there's something wrong with your sample. That's the coverage error. You're not covering people correctly. So to avoid this, you would want to sample more of the population. For instance, if you want to find out how tall people are, and you only have 3 people, it's possible 2 of them, if you only have 3 people, it's possible 2 of those 3 are basketball players. And in general, basketball players are taller than the average. So if you only have 2 people, there's more of a chance that it's not going to be what the whole population looks like. Also, you want to get better representation. Make sure you're not leaving anybody out. If you looked at the senators in the country, you might assume that almost everybody in the country is white. There's not good representation of other races. You got to look at the whole population, not just a small sample. Better representation, in the case of height, if you only sample men, that's bad. Because in general, men are taller than women by the time they get to high school. So you want to make sure that you're representing all of your population. The final type of error is called non-response. And this is kind of how it sounds, non-response, no responses. This happens if many don't respond. So if you ever go to a website and it says, would you like to rate your experience? Most people don't respond to that. Most people, unless they really hated it or really loved it, aren't going to respond. That's a non-response error. And there's a few reasons for that. A few ways that you can avoid this. One is better communication. Better communication. For instance, if you're trying to measure the height of everyone at Shortridge, don't message people on Facebook. Because as it turns out, nobody younger than me uses Facebook, so that wouldn't communicate. A lot of people just wouldn't respond. You'd only get old people responding. Another thing you can do to avoid a non-response error is give an incentive or a benefit. If you respond, I will give you a piece of candy. Right? That's a real thing that people do. I'll give you $1. Right? Give a benefit to responding. So don't make it unattractive or unappealing. Because if you just ask people, hey, do you want me to measure your height? If you want to be taller, if you're not happy with how tall you are, for instance, you might say, no, I don't want to do that. And then that would be a non-response. Okay, so 4 types of error. Sampling error because no sample is perfect. Measurement error. If you sampled okay, but the data you collected was actually bad. Coverage. If your sample doesn't look like your population. and non-response is because many people don't respond. So the overall idea from this, these problems are going to ask you, we collected this data in this way. We did this sample in this way. You always want to be critical. Be careful. Try to look for mistakes in what you see. You need to figure out, why is what the textbook is saying, why is it wrong? What could they do better? Okay, and when you're going to do your own experiments, collect your own data, you want to make sure you're asking the same questions. What am I doing wrong? What could I do better so that I make sure that my small sample looks like my population?